division. So this is something that always comes out, and this is what you guys will be using in the rotation part. Okay? So we will be multiplying two matrices. Very simple matrix right now. At the high school, you guys, you will only need to be doing up to 2 by 2 matrix multiplication, not 3 by 3 or a big size. And division. Okay? What you call the inverse. The matrix we will be multiplying is 2, 4, 1, 3 times the matrix 3, 2, 5, 1. Okay? Are we on paper view? Yes, we are. Thank you. So there we go. And so we'll be multiplying this matrix here. Now, remember the multiplication matrix will be multiplying row by column. Alright? So I shrink a little bit so I could fit on the screen too. Like me and Mr. Umanya could fit together in there. So there we go. So when we multiply this matrix, we'll be multiplying row by column. Two matrices can only be multiplied if we have a 2 by 2, and the second one is a 2 by 2, and this value and this value are the same. If not, we cannot multiply them. Okay? Please remember that, because they show questions like this in your CHC. Alright? So let's multiply this out. We get 3 times 2. Now put it the full work. We get 3. Then you put brackets to multiply, to represent multiplication, and then you put plus the 4 times 2. 4 times 2. Okay? Remember, 2 times 3 plus 4 times 2. That's our first value. Then we go to the second value here, which will be 1 times 3 plus 3 times 2. So 1 times 3 plus 3 times 2. Okay? Note what numbers repeat. It's the 3 and the 2. 3 and the 2, which is here. Multiplying this first set of values. Then you go to the second one. First row, second value. So it becomes 2 times 5 plus 4 times 1. And then you go 1 times 5. 1 times 5 plus 3 times 1. Okay? Let me see that this on the screen. Yes, it does. We are recording. Yes, we are. So, continue with our steps. Again, I'm just showing you all of the steps for your multiplying code. Okay? My advice is that you use brackets to represent multiplication. Some people like to use the dot, but what if this was a decimal? You get yourself confused, right? So my advice is to use brackets. So 2 times 3 is going to be 6 plus 4 times 2 8. 1 times 3 3. 3 times 2 and 6. Then 2 times 5 10. 4 times 1 4. 1 times 5 5. And 3 times 1 3. So that gives us the other step, which is then summation 14 9 14 8. So that's our result once we multiply these two matrices. Okay? The key point here is to multiply two matrices. Multiply them this way and then come down in that order. You can continue across this way depending on the amount of steps that you guys will be doing. Any questions with this now? Okay, make sure copy this down because we'll be using this to derive one of this if there was revision. Okay? Because I like to show you guys questions like this. It's an example. If I have 2 times 3, I get 6. True or false? True, right? But sometimes they will give you 2 times a number will give us 6. So how do we determine this number? Alright, so we're going to say A is equals to 6 divided by 2, right? So we'll be doing this now with matrices. So this is the same concept, alright? So let's see how this works out. So can I erase this now? So you can show that that's the same solution. So remember, this is the concept we want to get to, division, alright? We should already be able to add, subtract, multiply, and now we're going to go to division. So our result, when we multiply these two matrices, our result was 14, 9, 14, and 8. Let's say that's 2, 6, and 8, that's 14, 3 and 6, that's 9, 10 and 4, 14, 5 and 3, 8. Okay, that's good. So we have that. Now, then they give you a question like this. A matrix 2, 4, 1, 3 times an unknown matrix is equals to 1, 9, 14, 8. So we have to determine what is the value of this matrix. We already know what's the value, right? I'm going to use this so that we derive the same value so that we know that we are correct. So for us to do this now is that you are going to be working on what you call determinants. Okay? So you come here and you will start to multiply, but you will need to do this by dividing, right? So determinant is given by the equation 1 over a, b, c, d, a, d minus b, c. Okay? That's the determinant value. Make sure you get that equation is not given to you guys. And the reason why that's not given is because they expect you to know how to divide and an inverse. Okay? So remember what we did when we had multiplication. We said 2 times a number is equal to 6. We said a is equal to this value divided by this value, right? So that's what we are going to do now. We are going to divide this matrix by this. Okay, so now we need to find the determinant or divide this side by this. For us to do that, I'm going to take this piece matrix and put it here so I get my determinant. Remember that a matrix is given as A, B, C, D. That is in general. Okay? The A is here, the D is here, AD minus BC. Alright? Please remember the minus. So what you do now is that when you do this piece here, this is only the determinant. The inverse of it now will then be 1 over AD minus BC, and the matrix becomes DA minus C minus B. That's now the inverse of it. Okay? Now, please note this. This doesn't mean that the value will have a negative sign. It just simply means that you get a negative of that value. Alright? The A and the D will change positions. These two diagonals will just become the negative of it. So if it's a positive value, it will become negative. And if it's a negative value, it will then become not negative, positive. Okay? So just the opposite. So I'm going to take this value now, and I have here x is equals now to this information. I take my A and my B. So I take my A and my B, and I put here 2, 3 here, 2 here. I interchange their position, and I make the negative of these other two values. So I become -1, -4. Okay? Just watch what I did. I change their positions, and I made this negative. What you are doing is that you are finding the inverse of this for you to solve for this matrix. But you have one piece missing, which is this piece here. Okay? So 1 over AD means 2 times 3. So 2 times 3 minus 1 times 4. 1 times 4. Now, be careful here, guys. This is where you make mistakes. If this is a negative, and I said -1 times 4, it will be -4, right? Minus here, we then make it up positive value. So be careful here. So this now becomes 1 over 2 times 3, 6, take away 4, which is a half. So that half is the determinant of this matrix. So we put that half right in front here, 1 over 2 times the matrix which we have here, 14, 14, 9, and 8. So now finish it. We have just transposed this matrix to the other side of the equation. That's why they change sign and they got inverse. Alright? So now we can multiply this matrix by half and this matrix by half. That's up to you. My advice would be that you multiply the matrix solution by half last. This will be multiplied last. This is my advice. The reason why is that if you multiply this by this half, because this is a fraction, you might end up with a fraction here. And so when you start to multiply inside, then you will end up with more fractions. So my advice, you work with the fraction last. Alright? So you continue with the steps and put 1 over 2. And you multiply this matrix the same way how you multiply this one to get the solution. Alright? So let's do that piece there. I'm going to have here now 3 times 14. 3 times 14 plus negative 4 times 9. Please take note of the negative. Where am I putting it? Negative 1 times 14 plus 2 times 9. Remember, it's row times column, right? And then we go to the next one. 3 times 14 plus negative 4 times 8. 3 times 14 plus negative 4 times 8. I could have taken the plus here, but I prefer to leave it there, right? That's my last step. So negative 1 times 14, negative 1 times 14 plus 2 times 8. Close bracket. Alright? So then we continue. Bring down the half. We said that we're going to work with the half last. The last step. So now we work out this multiplication. 3 times 14 will give us 42. And negative 4 times 9 will give us minus 36. Now I'm getting rid of the plus sign because it's a plus or a negative, right? So negative 14, because 1 times 14 will give us negative 14. 2 times 9 will give us 18. And then we have here 3 times 14, which is 42. Negative 4 times 8, negative 32. Negative 1 times 14, negative 14. 2 times 8, that gives us 60. Okay? So we're running out of space here, so I'm going to continue this side. Alright? So we continue here. And I'm going to put half here still yet. And I'm going to start to work out this piece inside. So I end up here now. 42 take away 36, that is going to give us 6. Negative 14 plus 18 is going to give us 4. 42 take away 8, minus 42 take away 32 is going to give us 10. 14 plus 16 is going to give us 2. Close bracket. Now we multiply it by the half, or whatever fraction you actually have here. At times you might even end up with a negative value. That is okay, don't worry about that. So now multiply everyone by half. 6 times half will give us 3. 1 times, no, half times 4 will give us 2. Half times 10 will give us 5. Half times 2 will give us 1. This is the same matrix as what we have right here. Okay? So that's how you multiply a matrix this way and then find the unknown matrix if you have been asked that. We use this example so that we know that what we get must be this one here and in this order. Okay? So just go over this and tell me what you think about it. Any questions? Have questions. Questions like this come up in your CHC, guys. This is the determinant. Alright? You're going to ask you for this. What's the determinant? You will need to give this value. Alright? Remember how I get this. I interchange them and then I subtract by multiplying these two. Alright? Keep in mind that if these are negative, you're going to say a negative times this. You're going to get either a negative or a positive, but you must subtract it still. Right? So this subtraction has nothing to do with this sign. Just remember, these two do not change position, It's only these two. Because you are finding the inverse. What you have done here is that remember, when you multiply this way, this makes your x value, right? So when I change position this way now, then my x value goes down that direction, and so you can solve for that one there. Yes? This one? Okay, I just made up this matrix. I just said, remember we started today by saying 2 matrix multiplied gave us this. We got that, right? Then I said, what about if they had given you a matrix times an unknown matrix and they give you the solution? How do you figure out this matrix? Okay? So I brought back the concept and I said, 2 matrix, it's like saying 2 times a value is equal to 6. How do you solve for this? When you say times half, it's the same, it's the inverse of the coefficient, so it gives us a is equals to 3. So this kind of working is what we have done here. But because it is matrix now, we have to find the inverse of this matrix. For the high school level, you are only responsible for a 2 by 2 matrix inverse. That's not for So, I'll get 2 injections. So then, remember how you get this. And remember also guys, which matrix you actually work with. You work with a matrix from this side, not the matrix from that side. You transpose them, just change position, make a negative of it. Alright? If this is a negative, then this will become positive. The minus sign doesn't mean that they must be negative, it just means make the negative of that value. Okay? Questions? Okay, so let's see if you can work with one. You work with one this way and then you solve it to get to the unknown. Any questions with this? This is the matrix multiplication and division. Just remember this word, guys. Determinant. You will get to see that one of your multiple choice questions in your CXC maths. That they always ask you what's the determinant of this matrix here, and you want to figure it out. If they have letters, don't worry about it. You will get if this is A, then it will be 2A minus 4. That's your determinant. So you put it 1 over 2A minus 4. No, it's kind of
That's the determinant.
this?
No, that's the determinant.
This is the problem, right? Forget about this piece. I only let this piece up here so as to show that what we get here must be this one here, right? We started with this so that we get a solution of this product of these two matrices, right? Then we said, what if they give a matrix like this with an unknown matrix? So how do you figure this out? Well, forget about this piece here. Just imagine that this is the gift problem given to you. So what you have to do is that you have to find the inverse of this matrix by saying just multiply this two and then make the negative of this two. But when you multiply this two, you need to change their position. Remember, when you multiply this way, this two, when you multiply this way, you will get this value here. So when I change positions now, this value now changes positions as well. Okay? So when you move these values, you are moving your values on this side of the matrix. Okay? So that's all that we're doing here. You don't need to know about the 3 by 3 matrix. If they give you this thing like 3 by 3 matrix, and the CXC syllabus does not require you to find the determinant or the 4 by 4 matrix, only up to 2 by 2 matrix. Okay? And if they do multiply 3 by 3 matrix, multiply the same way. First and the first, second and the second, the third times and the third. And it goes that and that way. In order to take signs at UB, you will do something called abstract algebra, where you will have to multiply lower letters like a 6 by 6. Okay? But don't worry, this is the same concept, right? Just that it's with letters. Okay? So let me erase this now, and then let's figure out in a matrix. Okay? So remember how to work with those. So let me erase this piece here. Okay, so we're going to have two matrices here. 1, 4, 3, 2. We have here 6, 8, 4, 5. So let's multiply this out, get the solution, and then let us take this out so we get back the same value here. Okay? The reason why I want to use it this way so that you guys don't get a fraction on this side. Right? So we will then multiply this out, we get 6 and 32. That will give us 6 and 32, that will give us 38. Then 18 and 16, that will give us 34. 4 and 20, that will give us 24. 12 and 10, that will give us 22. So let's patch out this matrix here. Imagine this matrix is not here. Okay, forget about this matrix. This matrix is not here. So the actual matrix that we are looking for now is 1, 4, 3, 2. And we end up with a solution 38, 34, 24, and 22. Just note that you will not be given the matrix to multiply first and then solve for this one. I'm just showing you this so that you guys know that your work will do those numbers. So the numbers, the calculation will have to give about that same matrix. So we're going to leave this up here so that we get back to the same solution here. So let's try to multiply this out and work with this same method and get back this matrix. Okay? So let's do that. Remember, this is the multiplication result of matrices. This is the inverse of a matrix. So let's work it out. Remember, this is the ones that we're solving for. So this piece here is the old problem. This is the problem. This is the one that we're working with. This one. We're solving for this matrix here. You must end up with this matrix. Remember also, the answer for the determinant, this is all you need to give, nothing more. That's the determinant, alright? Because they let you throw the question like this, what's the determinant? The reason why you do it this way is that they give a problem like this and I ask for the determinant. They want to make sure that you know you did the determinant first of all. Okay? And then they're going to ask you what's the inverse of this matrix. They need to give them this. Right? This whole thing, you can multiply it with the half of 1. But like I said, the half, you multiply that last. Because if you multiply this by half, you will have this here 3 over 2, negative 2, negative half, 1. So you will be multiplying by a fraction inside. You will still get back the same solution though. Right? But just as a fraction makes it more complicated. And this is something that's in your multiple choice. This question, and you problem solving the structure questions also. Okay? Unfortunately, we do not have internet or else I would have passed it to the classes, okay? But I will stick this recording in the Moodle zone. 24 hours, 24 minutes of repeating. Maybe we will do this one here first and then we'll go over it. to master this, guys, because when you start to do this, these are a little more rotations. You need to be able to write two matrices. Okay? Somebody phone it. Check out. Let me put the recording on pause. Times, and most of the times they're going to be asking you, what's the determinant? And the reason why they're going to ask you the determinant is to make sure that you are getting the determinant first, and then they're going to ask you what's the inverse. Alright? So those two things. So I'm going to take this matrix and find the determinant. So remember what I do here? I flip this diagonals position. That's one. So when I flip them, the 2 comes here and the 1 goes to the bottom. Okay? Then I make the negative of these 2. So that becomes negative 3, negative 4. Alright? That's what I did here. But I need this determinant here. So I will say 1 times 2, 1 times 2, minus 4 times 3. 4 times 3. And that is going to give us 2 take away 12, which is equal to negative 1 over 10. Negative 1 over 10. Don't worry about that. Why 10? It's 2 minus 12, which is negative 10, but because it's negative, we put it negative at the top. Okay? So our determinant is negative 1, 10. Anyone back up to this point? No?
Yes, sir.
You got the answer? Here? Oh, remember the half was for the previous column, right? That's why I am looking at with A, B, C, D. Right? Just keep that in mind. It's 1/10. 1/10. So the negative is at the bottom, is still the whole fraction negative. Now, I bring down this matrix here. 38, 34, 24, 22. So I'm going to say now 2 times 38, 2 times 38 plus negative 4 times 34. Remember, row times column. Okay? First, second. But we put plus in between. Negative 3 times 38 plus 1 times 34. This times this plus this times this. Alright? Then we're going to say 2 times 24. 2 times 24 plus negative 4 times positive 22. Negative 4. I encourage you to put brackets. And 2. And then negative 3 times 24. Negative 3 times 24. And then plus 1 times 22. We are still up to the same steps, right? Nothing else has changed except that our fraction here is negative. Remember I said it would have been negative, right? So now we continue here. Well, here's not easy, right? So 2 times 38 is going to give us how much? That's 16, 76. 4 times 32, well that's 120. And 16, that's 136, right? So that's negative 136. Alright? Then, negative 3 times 38. So 3 times 30 is going to give us 90. 3 times 8 is going to give us 24. 9 times 24 is going to give us negative 140, right? So there's no need to calculate that. Calculate it makes for the demon.
No.
Yeah, that's the money. So 2 times 24, 48. Negative 2 times. Huh? Yes, you know.
The next one.
That is, we learned this. and 12, 72, negative 72. And 1 plus 22 will give us 22. So we are up to that point, right? So bring the negative 110 fraction on this side still. And so negative 72 minus 36 is going to give us 0 and 4, which is 40. Negative 140 plus 34 is going to give us 0 and 8, negative 80. This is negative 40, sorry about that. That's what because of the sign, right? And then 48 minus 88, negative 40. Negative 72 plus 22 will go with us negative 50. Now, multiply each value by negative 110, but negative 110, alright? So, negative 110 times negative 40 will give us 4, right? And negative 110 times negative 80 will give us 8. Negative 110 times negative 40 will give us 4 again. And negative 110 times negative 50 will give us 5. That's the same matrix as what we have here. Oh, that's 6. Where did it go wrong?
It was 6.
6. Alright. Where is it? 50 now.
Where go?
Nothing, that's fine. So that's 6 right here, right? So you have to be careful with the multiplication and the answer, right? Again, you note that I don't have any paper where I'm copying down everything, so nothing is memorized. Everything is like with fresh numbers that work with. For that reason, I take two matrices, multiply them, get in here, and then I tell you, let's solve it if we did not have this matrix here. Okay? So this is what we do. And this matrix must equal this same matrix here. So that's the inverse of a matrix. So remember, when you get a question like this in the structure paper, usually they ask you what's the determinant. So you have to get this. Okay? 1, 2. They're going to ask you what's the inverse. Now, the inverse is a little bit of a little tricky question because this whole thing here, guys, is actually an inverse. Okay? Some people, when they ask them for the inverse, they leave the fraction on the side, and because they don't want to do any multiplying with fractions. If I had multiplied this with fraction, then this would have looked like a negative 1/5, 3/10. This would have looked 2/5, and this would have looked like negative 1/10. Now imagine you multiply two matrices with a lot of fractions. It becomes more complicated. You will get back the same solution, but the idea here is that this is a problem. Now this is actually an inverse matrix. Okay? So you could give it this form, or you may give it in this form here. Either of the two is still the same solution. Okay? Okay, now if they ask for the inverse matrix, give them this. But when you multiply it here, don't use that. Use it this form. Okay? The reason why is that they just want to make sure that you have determinant, which you did do, and 2, that you know that you will use it the inverse. Now you carry your multiplication and you solve for that. Okay? So can we do a next one like this? Everyone okay with this? So let's start with 1, where I will give you the numbers again, we multiply across, and we'll get a value, and then see what then happens. So okay, 1. Let's do this 4, let's do this here 3, let's do here this 2, and let's do
1.
Okay, 1. When you multiply those two matrices, you will end up here as 1 and 12, that's 30. 2 and 9, that's 11. 4 and 8, that's 12. And 8 and 6, 8 and 6, that's 40. So I want you guys to solve for this matrix here when you are given this side. 1, 2, 4, 3, 13, 11, 12, 14. Solve for this matrix, the same method, get this matrix here. Okay? We're leaving this up here so that you see that that's the same matrix that need to get back. Just remember, in your exam, you will not be given to multiply and then solve for it. Okay, I'm only using this so you see that you're working with whole numbers. So whatever answer you get here, it needs to get back with whole numbers. Remember, first of all, the first step, determinant, then the inverse, which is this combination. Those are two first questions that they're going to ask you, and then the final solution. Let me put this on a pause. For CXC, they're going to give a worksheet right on the side. You could do all the working.
You can use calculator.
Yeah. For CXC, I think you will be allowed to use calculators if anything. But if anything, guys, these numbers like this, don't worry about them. Just multiply them one by one. Work with them, okay? Small numbers. Remember, if you're having fractions, don't work with big fraction values. Reduce them if you can reduce them. If you have mixed number, change it to an improper fraction. Alright? With multiplication, addition, subtraction, division, change it to an improper fraction. If it's decimal, try to change it to an improper fraction if you feel more comfortable working to a fraction, if you feel more comfortable working with fractions. Okay? Is that clear? Okay, so remember, when you work this out, you should get back the same value here. So, yes, we'll hold the solution. And remember, these are known fresh numbers that we have selected. Nothing more than that. Let's go quickly to the solution and make sure we get back what we started with. So, we get this matrix and change pole positions. We get 3, 1, -2, -4. So we say 1 times 3, that's 1 times 3 minus 2 times 4, which is 3 take away 8, and -1/5. 4, -1/5. That's there, right? So the next matrix comes here 13, 11, 12, 14. Please remember that if you wanted, you could have worked with a -1/5, but then you will have fractions inside. You don't want to work with fractions. Okay? So you come here -1/5, and you are going to say now 3 times 13 plus -4 times 11 and -2 times 13 plus 1 times 11, then 3 times 12, 3 times 12 plus -4 times 14, then 2 times 12 plus 1 times 14. Alright? Please remember that. Right now here we -1/5 and 3 times 13, that's 39. That's -44. Here -26 plus 11. Here 36 minus 40 and 16, 56. Here -24 plus 40. So bring -1/5 here still, and you start to work with this. That's 5, -5. Here work that was 11, right? So here we end with 5 and 1, that's 15. -1/15. Alright? Here you work with -20. Here you work with, you get -10. Right? -1/5 times -5 gives 1. -1/5 times -15 will give us 3. -1/5 times -20 will give us 4. -1/5 times -10 will give us 2. And that's our solution as this one here. Okay? So that's how you do the inverse of a matrix. Please remember, when you get values of this form, always go with the then get your inverse. Okay? If they ask you what's the inverse, you can multiply the fraction with everything inside and state that as your inverse. But don't use that to multiply it here. Use this form because you want to work with the fraction last step. Okay? That's the last step. There's no guarantee that you will be getting multiple numbers. You may get fractions, you may get negatives inside as well. Okay? And that would be for matrix division. Alright? So this is how you divide matrices. Alright? So we did multiplication and division of matrix.